So, good morning, everyone. Welcome to this demonstration of artificial intelligence. And I call this as a word of mouth. And you will know towards the end of this demonstration that why is it word of mouth. Just to give a glimpse, it's basically the more we speak, the more data we create. And later on, you will see that how data is important, how much importance does the data keep in our day-to-day world nowadays. So I better call it as word of mouth. Through this course, I will be mentoring you, training you along the duration of the course. And I am a trainer, consultant, and mentor for Internet of Things, where the machine wants to speak, machine learning, where machine wants to learn things, and AI for smart activity. I've also published one of my research on machine learning curve fitting, and I'm also a master's in electronics from Lithuania, Europe. Introduction of AI. So it consists of machine learning, neural networks, and deep learning as generally, but not the only part is these three. So AI, machine learning, and deep learning are sometimes or most of the time interchangeably used, but we need to make real clear boundary about what deep learning, machine learning, and AI is. Now, deep learning is a subset of machine learning, and I'll tell you what and how deep learning is important. Where machine learning is a subset of artificial intelligence. On the right side of the diagram, you can see artificial intelligence is considered to have a sense, reason, engagement, and learning. Robotics, computer vision, natural language processing, voice recognition, etc. While coming down to machine learning is unsupervised, supervised, and reinforcement learning, and it uses some kind of method, let's say decision tree, uh, regression, and things like that. While deep learning uses neural networks, and I'll explain you later on why and what is that. Well, generally considering AI is a one-man show, this is what I call it. And also Professor John McCarthy, who is considered to be the founding father or the father of AI, he says that the science of engineering, of making intelligent machines, especially intelligent computer programs, it is generally to make computers resemble more of humans. Hence, you can see all the components that are very key important part of humans, say computer vision, natural language processing, voice recognition, some robotics and motion, pick and place, etc. Planning on optimization in your mindset and knowledge capture just to get the source of data. So all these things generally uh, cover up what a human being would be like. Now there are different types of AI. So generally before that we need to consider, you can consider AI as a pile of if and then statements. For example, if you do this, if you do that, if there is any image that you already recognize that as face recognition, part of computer vision. While if you don't recognize, if else reject. If you recognize, say hi, else remove. So kind of you can understand that as a if then else statement, or a kind of a complex statistical model which you apply on the data in order to get and extract insights from the curve. For example, if you have a data that represents stock market, you would basically apply some kind of model, complex model, which resembles that with the spikes. There are different methodologies used in order to invest or take down money from stock markets. But then generally you try to fit a data or a model on the data so that you can extract meaningful information. Some of the AI we can talk about is expert system, swarm intelligence, Turing test, neural networks, fuzzy logic. Now, if I have to explain fuzzy logic, it is basically some of the decisions which are yes or no, and sometimes there are decisions maybe and maybe not. So fuzzy logic try to help you understand the decisions which are vague. Let's say not even yes or no. Now these are considered to be weak AI. So some of the critic of uh, artificial intelligence says that if a machine is able to do a task, it's no more a intelligent. because we humans don't keep doing one task all through our life. So if you're able to understand the pattern, you are not smart enough. If you're able to understand the code and you write the same code again and again, it's not intelligent. Rather, it is just copy pasting, right? So they say it's the weak AI which is present nowadays, and it was also termed as narrow AI, and it only performs some dumb operations, saying detecting face, recognition face, recognizing voice, understanding the text, modeling the text, and generating some questions, etc. As I've explained you about fuzzy logic, natural language processing is what we know already. I'm trying to speak something and you are able to understand something. How? That's the reason why I tell AI is a word of mouth. So I speak something and it is a audio data. And some of you would be understanding in English, some of you belong from Hindi speaking, some of you belong from uh, uh, kan, uh, uh, Telugu, Tamil, all these languages, different languages, or Malayali or Bhojpuri, whatever it is. But then you had that intelligence of understanding different languages or your native language at least. So whenever I try to speak in English, you already have those text in your mind saying, if a person says you or someone has already taught you, probably your parents, if someone says hi, you need to respond by hi and don't talk to strangers. So you have that intelligence in your mind. If someone says, what's your name? So you have that tag name, right? So you would say, yeah, my name is so and so. So that's basically a understanding in your mindset. And then you apply some kind of verb. You know that if someone says he is going there, so naturally you understand in your mind that the person who Sharik is talking about is a man or a boy because it's about he. So you have those things of understanding noun, verb, proverb, and details. This is what AI uses, and it is called POS tagging, part of speech tagging. And then it try to make sense of whatever someone is trying to write. Okay. And then we have neural networks. Now, first of all, before speaking of neural network, I really want to dig down inside about machine learning. There are different types of machine learning: supervised, unsupervised, and reinforcement learning. Well, you can understand supervised learning as something like you have your parent, or you are a newborn child, or somewhere between 0 to 5, and someone speaks to you saying hello, hi, or changes his dialogue saying hello, I, and things like that. But you don't know how to respond because you're not that matured enough. How your parents deal with it? They tell you, son, say hi because he's your elder, or say hello because he's asking you hello. So he, your father or your mother, is being your supervisor, trying to guide you about the features or about the text someone is trying to speak, and then telling you the response of this is this. So that's your label data or target. Similarly, someone says you, what are you doing? So you sometimes you tell I'm playing. Sometimes you look at your father in an innocent way saying, what do I respond to this? So your father or mother says, respond that you're playing. So that's your supervised learning. That means you have some features or some data to act upon, and you also have a target value that you have understood it in past experience. Now, after teaching you, you don't necessarily have to ask your father or your mother every day and then. So after you cross 5 or 6 or 10, you already know how to talk with strangers. You already know how to talk to your parents. You already know how to talk to your seniors, juniors, and things like that. That's your supervised learning. You have your previous experience and you try to predict or try to work upon in future data. So whenever a new data comes in, you have your well-trained model of your early age, and then you try to respond accordingly, right? And you might have heard of common sayings in among our Indian parents saying, "पढ़ोगे लिखोगे बनोगे नवाब," and "खेलोगे कूदोगे बनोगे खराब," which by that they mean is you play a lot, you become a bad person. When you study a lot, or you become a good person, or like you become successful. Why is it so? Because they have understood from their past experience with their friends, with themselves, or among their peers that if you don't work hard or you don't study well, you will eventually be a unsuccessful person, and so on and so forth. That's your supervised learning. You work on your experience, train yourself on experience, and then try to predict on future data set. And comes in your unsupervised learning. So your unsupervised learning is basically when you don't have anyone to guide you, and you try to make sense of the data. And all you do is for example, you can understand a boy trying to play with different uh, shapes of cubes or some solid structures. So he has some cube, he has triangles, he has pentagon, hexagon, and other things, or a square ball. So you don't really have to tell them, put the squares in squares, put the triangles in triangles. So what you do is the boy itself, or if he don't know, he would just take away everything and dump it into his cardboard box. But then if you do no segregate it, keep them in decent way. So what naturally he would do is, to most extent, he will be able to play cubes all together, triangle all together, while pentagon all together. That's your unsupervised learning. He don't know how to label these data, while he know how to cluster them together so that they almost resemble same, right? And not surely he won't be able to assemble them or cluster them to be very specific. So you come in and try to optimize things or tune parameters, saying that, you know what, this maybe looks like a cube or pentagon or things like that, and then it becomes more perfect clustering or grouping. That's your supervised learning. Well, when it comes to reinforcement learning, I think you might have played a game called hide and seek in your early age, where you hide and there is a seeker who seeks for you. And reinforcement learning is kind of a hit and trial method, where if you hit and you are able to get something good out of it, you say, okay, keep doing it. So it's kind of a you reward yourself. But then if you do something, if you try something and you get negative out of it, so you punish yourself saying that, no, don't repeat such thing. That's your reinforcement learning. Now, in order to understand that, you can consider a game of hide and seek where you try to hide and someone is trying to seek you. But if you don't know that, guys, consider that you guys don't know about each other, how smart you are. So you start from beginning trying to play around and start with your hiding or seeking. So as a seeker, you would go and you don't know how smart these people are. So you misunderstood them, or you undermine their capabilities, and you just went inside the play area. And some of the hider, they came in and caught you. So then after this act of yours, you rewarded yourself negative point, punish kind of, and then you went back thinking, okay, so these guys are pretty much smart. So rather, I will be very careful and run to the play area fast, swiftly, and try to find them all quickly. So they're not able to respond quickly. So then you have become smart enough, you apply that tactic, and then you eventually become successful in that. So that's your rewarding. So you say, okay, this is the minimum requirement of this play. Again, the seeker, the hider, who you found first, he becomes smart, and then he goes back saying, okay, the seeker last time was very much smart, and even the hider is become smart. So he would go and do the same thing and found her. So this guy now try to uh, hide somewhere close to the person who is seeker, and then he caught him. So that's how we play the games and become smarter about the audience. And this is called your reinforcement learning. Now, coming to the applications, I think I skipped something like neural networks. Now, when this thing is done about machine learning, there comes a time when you're no more able to make or tune the parameters according to specific requirement. There comes your neural networks. Just like our brain cells that we have, we are basically having a lot of neurons or neural networks. which helps in transferring information from one neurons to another, trend rights and other ends. So these neural networks are basically based on bias and variance. That means if for example, if your marks is somewhere around 99.99%, so neural network will give some biasing or add some weight to it. Try to make, if it is possible, try to make it 99.99 or 9. Make it more perfect. So there are limitations to machine learning, hence why we have switched from machine learning just to deep learning, of which the specific technique is neural network. And we use that in different applications, computer vision and everything. So in depth or in brief of it, it's basically some of the hidden layer, which is your bias and your weight, kind of some kind of model, and then you have data, then you have an output. There are applications of AI. Some general application that I can speak of is interactive AI, which is chatbots, smart personal assistants, or Cortana, Siri, etc. Text AI, visual AI, functional AI, analytics AI. So you have sentiment analysis. For example, if you have some of your posts, you might have realized that Facebook or Twitter or Facebook or LinkedIn have come up with various emote icons. So if you like a post, you sometimes love that post, you care for that post, or you just like it or you just hate it, right? So these are nothing but sentiments of general sentiment of humans. So what it does in background, it takes this data and perform sentiment analysis, saying that so many people like this post, so many people didn't like it this post, and most of them loved that post. So you can get and store this information in your database and try to promote your clients, saying that, you know what, if for example, I'm a bit switching it. So if for example, if I had a company called Days Book and I had such kind of a feature, so I would collect such kind of sources and sell it to big clients, saying that your audience in India love watching Shah Rukh Khan movie, for example, and the category they'll do how they respond to Shah Rukh Khan post is mostly by love. So how about when you're launching a product, take Shah Rukh Khan as your brand ambassador, and hence we can see Shah Rukh Khan is all in fair lovely cream or some kind of things. Yeah. So TRP, right? The amount, how many people love Shah Rukh Khan, or etc. That's your general AI. While specific AI, there are this AI being used in customer service, say MCQs, multiple choice chatbots, virtual agents, bot assistant agent, real-time emotional analysis, intelligent assistant, and content creation or content curation. And there is also a type of AI where you can try to generate the questions and answer from a given text. So AI is already advanced. Now, based on your type of application or the type of AI being used by different companies, you can have a look on this graph, which stands with narrow AI from on the x-axis and goes to deep AI, which is continuously learning. So you have chatbots. So it says on the left, on the y-axis, you can see mass adoption, how it has been adopted with people or customers. So you can say chatbots are nothing but narrow AI because it's NLP purely. And then coming to Siri, it's a bit smart, but it's a little more towards the deep AI, while you have Deep Dream, Watson, AlphaGo, Autopilot by Tesla, Einstein. So these are dedicated AI which has been developed by some companies or some smart engineers. So their level of adoption, Watson is not yet customer adopted, right? But then it's more towards deep AI, which is continuously learning from the data that we are trying to generate. I hope most of you have heard of the story about Watson. And there are a lot of companies that are built around this AI. So you can say you have conversational AI, you have vision AI, you have automotive, robotics, and ad CRM, etc. IIoT, they are one of the great source of generating uh, your data for AI. And there are so many companies that are built around this. So you have H2O AI that's got a whole framework around it. You have so many companies that are working on AI. But then not to really be confused about that every single company is AI based who claim to be AI based, because there was a survey in Europe that suggested that and expressed that not many companies who says, or specifically 40% of companies that speaks of they are built on AI are not actually AI. So you can understand that considering or understanding the concept of AI and machine learning neural networks, you really have to be very smart enough to use that into your product. Now, there are a lot of HRs or there are a lot of people who don't know how to hire for data science. They don't know if they should hire an AI engineer or machine learning engineer or a computer vision specific engineer or etc. So for I've seen for this could be possible that people love or want to hire for computer vision engineer, but they give your requirement for AI just to make it general, right? So it's very quite new to people, although it's been developed over hundreds or 50 years. So it's quite new for people to adapt to it, to know how to hire for it. And hence you can see HR are taking trainings about technical HR hiring. So they know about the technology overview, like what to hire one, who to hire it. And then they become smart enough to hire even technical role. Okay. Coming to machine learning, where I've already spoken about some general what are supervised, unsupervised reinforcement and recommendation. Now, there are different things or algorithms or type of problems that we need to be very sure about. So in supervised learning, there are two types of methods, which is classification and regression. Now, the type of problem that classification help us to understand or solve is based on, for example, based on weather condition, past experience, you will predict if there is possible to have a match or not. Or if you have seen your fathers or forefathers saying that, you know what, there is less of humidity and there was a lot of heat today, so it's possible that there's gonna be rain because of their past experience, right? So, and then, so you're trying to predict or classify if there is going to be a rain or not. And if there is going to be rain, so you will have your past experience if that rain happened or not. Similarly, you have a problem where you try to classify if a patient has cancer or not. Okay. So that's your classification type of problem. When you also have regression type of problem, where you based on age of animal, you try to predict age of animal based on the fossil data set. So, for example, if you have heard of uh, uh, wolf or mammals, or let's say mammoths, the scientists have said that mammoth is about to come, or there will be time where mammoth will be regenerated, and they have let's say predicted, or you can say they have found out the estimate date when mammoth was present. So 2000 years ago, 3000 years ago, and 4000 years ago. So this is how you can use regression in order to predict the age of animal, how how much, I mean, what's the age of that animal, and then you can go back in the time and then try to find out what when was this animal present. Coming to unsupervised learning, one of the common example or common application of clustering is anomaly detection. Trying to figure out who's weird. So it's kind of an odd one out. So if you have one of your friend who behaves weird and is insane, not to say that, but he's insane. So you would try to say that, you know, just avoid him, right? So that's your clustering used for. And then comes your reinforcement learning, where you have no clue of output, as I said, rather you learn every step. So humans are basically a reinforcement model of learning. So you learn every step unless you don't want to learn. So if you don't want to learn, you won't grow, right? And then it comes your recommendation system or to suggest some kind of a content. I hope you understand some classification and some different type of problem that we have in machine learning. How to become an machine learning or a machine learning expert? You need to know good and bad of any algorithm. If you don't know where to use which algorithm, you won't be able to apply it in a expert manner. What do I mean by expert manner? Because if you don't know how that algorithm is being used, you won't be able to apply that into different data set or combine two algorithms in order to improve the output. So that's, you have to be really feeling that algorithm, right? And practice algorithm in variety of data sets in order to check how robust that algorithm is. Work on variety of data sets, so you don't have to just work on Titanic, if that ship was sink, if people would died or not. So these are like standard data sets. We will be in this course try to extract some variety of data sets from online and try to work around that data set. And the most important part is keep learning. Whatever we learn in this course has already been surpassed. This doesn't mean that this has got outdated, while this means that you need to know the basic knowledge of what we are trying to teach here in this course. Also, towards the end of this course, I'll tell you what are the industry standards that I've been using and some of the tricks that I'll be sharing with you, such as you don't have to work around with normalization and etc. All these things like basic pre-processing step, and you just import one library. You have some 3 to 4 lines of code. You generate the data and visualization, and you can generate some basic report. So one of the example is AutoML. So you don't really have to write in all these data, tune parameters. It is all done by just 1 or 2 lines of code by using AutoML. And also you need to know about the tools properly. You don't have to be a geek or a damn good coder. Rather, you need to be smart because you're going to be a machine learning engineer and not a coder or a practicing coder or etc. like that. Some of the job type of samples you can see in here. So the most demand library or frameworks or modules is basically your TensorFlow, Keras, NLP, and NumPy, Scikit-learn, Matplotlib. So we try to keep our course. We are going to keep our course as general as possible so that you fit in most of the requirement. And it's very important whenever you try to apply for a machine learning job or try to switch your existing job to machine learning, you have to write your tags that you learned. So people have an attention to not just your projects but also about the tags that you use in order to propose um, your job. Okay. Now, as for example, I can just switch back and try to give you a live example of AI. I'm gonna switch to right. So I'm gonna share with you this application. I hope you're able to see this. Great. So we have this. Okay. So we have this thing called experiment with AI. So I'll go with this experiment with Google. Right, and it's open. I mean, anyone can use this. So we have this experiment where Google team is trying to develop some algorithms or AI stuff and make it public, so you and I can use this, right? So I'm going to just use some AI experiment. Now, I'm a newborn child. I'm considering myself a newborn and try to teach me how to draw. And you can see that it uses a neural network and try to understand what are you basically able to drawing. I mean, what are you considering to draw? So it gives you a label, draw a bicycle. So it's a label that you know how to draw. I mean, you know that you have to draw a bicycle. So the output is already given, right? So as you can see, as soon as I start this game called Let's Draw, it says draw scorpion. So they have this in mind that a neural network output is going to be a scorpion, and they have already trained on multiple data sets. So whatever you try to draw something similar to scorpion, they will be able to understand that. So I don't know how to draw this scorpion, and I'm just gonna say something like right here. All right. And I have something like this, while a scorpion might look like this. uh, I it was wrong. So a line, that's easy, right? So it understood that it's a line. Flamingo, so that's a bird. So I think I can just draw a bird. um, I'm really an expert of drawing basically. So it's a seahorse. Great. uh, Great. And whatever it is, it's a dragon. It looks like a dragon. Picture frame, that's easy. I can just draw this picture frame, and there you go. Great. Peas. Oh, that's a peas. I don't know how to draw peas. Well, okay, yeah, the peas is with this. Ah, yeah, point brush, etc. like that. I mean, it can go forever. So I can just draw this last thing and give a try if I'm really good at drawing. Oh my god, that's a job. And there you go. Wall of China, great. It's a belt. It's a net, and ah, so you can see that how expertly I did it, and it has said that our neural network figured out two of your doodles. That means I need to practice a lot. So second experiment that I want to test is where I'm a kid and want to learn or try to know how to understand people or how to understand people. Or I can build such kind of a system of AI which when a child hover over some things, so it will tell that that's a pencil box, that's a person, that's a mobile phone, etc. like that. So I'm going to use a experiment with this teachable experiment, and here I'm going to give a some pictures, and it will be able to recognize this object. So you can see it's a metal and not metal, it's a tree, it's a wing, all the things. If we want to test it live, so you can perform this audio project, post project, and image project. So I can just start with labeling this class, so it's a supervised type of learning. Coffee. So I'm going to add my or start my webcam and see this, how the coffee cup of mine looks like. So start webcam. So I can show it here and take some samples. So you can see it is taking different samples of it, right? So I think 139 is good enough. I'm just gonna go down and try to add another class of this, which is your earpod case, right? And then I'm going to start with this web. And let me just start and get the data, right? So this is pretty much good. Okay, that's enough, I guess. And now I'm going to train this model. Okay. Now you can understand this. This is main part of it. So you have some classes that you have suggested or labeled, and then you have data set of it, and then some kind of model you are putting in some kind of model and training in it. You will see in that like had we used small samples, it would have been trained quickly, but then we want to train it more samples so it is able to understand it. Oh my god. Oh my god. So it will take some time, so let me just do this again. Let it be class 1. There you go. And then you have second thing called webcam. Right? I'm just gonna train the model now. This guy just sitting behind this is trying to train a model, and now after 50 trials or epochs, it will be able to uh, train on this data set and try to predict what is that you're trying to show. Is it a class 1 or class 2? You can understand, you know about class 1 is earpod case and class 2 is a coffee mug. So now whenever I fire it or start with it, it will detect or what is it? So you can understand that this is a object detection kind of class. So we need to wait a little. Till then you can't have your coffee. Then yeah, it's done almost. Now it says that okay, so this is your class 1, right? And now this is your class 2. Great. So I hope you have understood this concept of neural networks on computer vision, and you like this demonstration and presentation as well. And with this, I would like to conclude my training or demonstration, and would like to pose or ask you if you have any doubts or if you are very curious about anything. Feel free to question me now, or if you have anything that you wanted to ask and then you realize it after you have finished the demonstration, you can always mail Tra and or MagisterSign representative, and then they can get to me and then I can clear it out. So is there anything that you would like to ask to me? Great. So I understand or I assume you have understood it, at least the basics of it. If you feel this is what I do in all my webinars or demonstration, I want everyone to take part in it. Would love to have everyone taking part in it. So if you feel AI and machine learning has scope and it has potential to give rise to you on your present career, so I want you, most of you, to start writing something like hash, something like I feel. If you feel this and if you see the potential, so I want you to write in the comments or in chats, hash I feel. Can I have some few? So Harsha thinks that it's great potential. If we had 50% of people who consider this as potential and think that there is a potential in it to give rise, it's good to have some hashtags in your chat. So just put hashtags I feel. So let's make it more trending here. Thank you, Jivita. Krishna, we are a community of learners and explainers. So can I have at least 60 to 70% of yes? Yep, great. So I think most of us feel that it's a great potential. So thank you everyone, Kavita, and yeah. So thank you everyone for attending this demonstration. I hope you got insights of what AI and machine learning is, and you don't really have to search on YouTube what is AI, machine learning, and deep learning. I wish and I want you guys to take up this course, which is going to start roughly in this month and or next month, and so we can learn together and explore things. So because the trend is changing and the lockdown things are getting relaxed, so as soon as the lockdown finish it up and the things are relaxed and people are hiring for these roles, so this is the time where I'm training a lot of people in these technologies, and as soon as the things relax, damn, I mean the requirements is going to just flood with experienced engineers or freshers because they are really putting in a lot of time in order to learn machine learning, data science, and etc. So you know there are many institutes in India, so don't think or don't delay anything that you want